All right, guys. Good morning, everybody. So today is the last session of the course. On I have a couple of announcements to make. Tomorrow, Thursday, the in-class test will begin at 1 p.m. UK time. As tomorrow is the 16th of December, Thursday, and the in-class test will finish at 1 p.m. on Friday, the 17th of December. So you have exactly 24 hours to complete the in-class test. The test will take the form of the previous years. So it's one question with 3 parts. The first question will be like state the extremal types theorem. The second part is to state the 3 conditions. You remember the 3 conditions, the necessary and sufficient conditions for each of the 3 limits to hold or exist, right? So it's like this. This is from last year's exam paper. Hope you can see this. This is the part where you need to state the extremal types theorem. This is the part where you need to state the necessary and sufficient conditions for each domain of attraction. And the third part, it will be something similar to this, right? Where you need to show that given a class of distributions, show that F and G belong to the same domain of attraction. So to do that, I think there are quite a few questions on the course web page you can see. Like every past exam paper has a question like this, right? Where the last part of the question is to show that F and G belong to the same domain of attraction. So what you need to show is that you need to do it in 3 parts. First, assume that G belongs to the Gumpel domain of attraction and show that F also. Then assume that G belongs to the Frechet domain of attraction and show that F is also. And finally, assume that G belongs to the Weibull domain of attraction and show that F is also. Okay, so those are the 3 things you need to show. All right, so that will be the format of the exam tomorrow, or starting tomorrow and finishing on Friday. And the test will account for 10% of your total mark. The exam, I still haven't figured out the date of the exam. Some of you may know already what the date is, but I will send you later. But the exam will be in January next 2022, and it will account for 80% of your mark, right? And the exam will contain, like this is last year's exam paper, I'll show you. This is last year's exam paper. There will be 2 sections. There will be 2 sections to the exam paper. There's section A and section B. So section A, so this is question A1 from last year. Section A has 3 questions. The first question will be on the bivariate extreme Pauli distribution. So given a density or given a joint density or joint CDF or joint survival function, you'll be asked to determine the corresponding bivariate extreme Pauli distribution if it exists, right? Okay, and that's the first question. The second question in section A will be on copulas, right? This is, I hope you can see this. If not, is it Zoom problem? Zoom? All right, okay. Yeah, the second question in section A will be on copula. So given functions, you will be asked to check if the 6 conditions are satisfied or not, right? And the third question in section A will be this. So this is like given as joint survival function, you'll be asked to check whether it is a bivariate, whether it corresponds to a bivariate extreme Pauli distribution. There we are. And then you'll be also asked to determine the joint CDF, the joint PDF, and the conditional CDFs, right? So I did questions like that. I mean, every exam paper has a question like this, so you can check. So that's section A. Section A, as I said, has 3 questions: A1, A2, A3. Section B will have how many? It will have 5 questions. It will have 5 questions. So the first question will be of the style of the in-class test, right? So there are 3 parts. The first part is to state the extremal types theorem in full. Part B is to state the necessary and sufficient conditions for the 3 domains of attraction. And part C is to show, you'll be given something like this and asked to show that the F and G belong to the same domain of attraction, right? So that's B1. That will be B1 in section B. And B2 in section B will be like this. It will be, so you'll be given 5 different distributions, A, B, C, D, E, and you'll be asked to check which domain of attraction they belong to, right? Okay, so here you're given 5 different distributions, asked to check which domain it belongs to, if any. And B3, the third question in section B, is on VAR and ES. So it will be on compute the VAR or calculate the VAR and ES and also do estimation of it. So you'd be asked to not just compute it, but not just calculate them, but also do like ML estimation of the VAR and ES, right? So that's question B3. Question B4. Question B4 and B5 will be on portfolio theory. So here, like in this question, B4 is on sum, right? So in other words, total portfolio loss. So B4 is on total portfolio loss. This last year it was, and B5 is on maximum portfolio loss. Sorry, minimum portfolio loss. All right. So B4 and B5 will be on portfolio theory, which we did. Right. So that will be the format of the exam you will see in January next year. Right. So as for tomorrow and day after tomorrow, the in-class test, I already told you what the format will be, and the course website contains many questions, many papers, it contains many questions that you can practice on, right? So if you do all of them, you should feel confident about tomorrow, right? And Friday. And I will try to mark all the tests on Friday and we'll try to return them to you before the end of Friday. I cannot promise, but I will try to do that. Okay, so you will get your mark hopefully on Friday. And as I said, the mark is out of 10, yeah? So it will be marked out of 10, okay? All right, guys, any questions you guys have? Or is there some questions you want me to do, like some past paper questions or past test questions you want me to do now? Please let me know. So this is basically a revision session. Veronica, you okay? You have some questions?
Yeah, I actually wanted to see if we could do the question where we wanted to check which maximum attraction we wanted to use. We made 5.
Yeah, this is last year's exam paper. Yeah, so these are the 5 in the last year's exam paper. Which one you want me to do? Oh, B? Okay. All right. So the question is, this is B2, part B. You're told that f of x is equal to 2 over pi arcsine of root of x, yeah. And the question is, and you're told that x is between minus and plus infinity. So it is clear that because of the support, w of f must be plus infinity, right? Okay. All right, guys. So let's check condition 1 first. Condition 1 is that the limit as t goes to infinity of okay. And so this becomes the limit as t goes to infinity to pi times arcsine all right. Now, what do you think the next step is gonna be? I mean, what do you think the next thing? What do you think the next thing we should do?
Substitute arcsine for the function, check down the ways.
Is it relative exponential? I don't think so. What's the, I forgot, what's the derivative of sine? 1 over square root of 1 minus x squared. All right, so what the next thing I'm going to do is I was just checking what the derivative of sine was. So the next thing I'm going to use is I'm going to use the L'Hopital's rule, because arcsine is really difficult to deal with, right? So let's try to use the L'Hopital's rule, right? So you should differentiate the top, you get minus 2 over pi times, I just checked the derivative of arcsine, which is 1 over square root of 1 minus x squared. So it's gonna be the square root of 1 minus t minus x gamma t, right? Then you have to differentiate this guy here. It's gonna be 1 plus x gamma prime t. Okay, correct. All right, correct me if I'm wrong. And this will be okay. All right. So, so this becomes the limit as t goes to infinity of these two guys will cancel, right? These two will cancel out. So you get okay. Are you with me, guys, so far? Now, for type 2 to hold, the limit of this must be e to the minus x. And it doesn't look like it doesn't look like you're gonna get this to be equal to e of minus x. I think so the conclusion is that condition 1 okay, that's not hold, right? So let's go to condition 2. Condition 2 is, I'm sure you know what it is. So let's go to condition 2, which is so condition 2 is about checking the limit as t goes to infinity of 1 minus f yeah, yeah, you remember this, yeah. So you put yeah, you guys okay with me so far? All right, now I'm gonna use the L'Hopital's rule. So I'm gonna differentiate the top and the bottom with respect to t. So you get in the top, you will get so the square root, yeah, square root of this times x. In the bottom, you will get okay. All right, these two guys will cancel. So this what you have is the limit as t goes to infinity of all right. Now we know that t goes to infinity. So is that sine root of x? Okay. This is which is not equal to x to the power minus alpha. So when alpha is positive, so again condition two does not hold. Right, because for condition two to hold, excuse me guys, sorry, for condition two to hold, the limit must be of the type x to the power minus alpha, where alpha is positive. And the limit that we are getting here, unless I made a mistake, is did I do this right? Just a minute. Just a minute. T. Should differentiate this with respect to t. Tx. Yeah, okay, I think it's right, yeah. Yeah, okay. So condition two does not hold. Yeah, so it is BID2 square root of Tx. Just a minute. Rob, I'm just following you. Just give me a sec. So if I go back here, this is right. Now, if I differentiate this with respect to Tx, oh, sorry, yeah, you're right. Yeah, you're right. Yeah, sorry about this. So if come on, the derivative of this with respect to t is gonna be root of x so even the first one, I guess, is wrong also. So it's root of x times the derivative of with respect to t is going to be yeah, and the same thing here. You should do, yeah. Is that right now, Rob? Can you check this? So this should be t again, t. You should differentiate this. Yeah, you get this. So this becomes root of x. This becomes root of x. This becomes root of x, which is 1. Correct me if I'm wrong again. I hope this is correct. Yeah, is this correct now? I hope it is. Huh? So the answer is 1, yeah. And also in the first part, I think I made the same mistake. For condition 1, when you differentiate this, thank you, Rob, for pointing this out. You get this, and then when you differentiate this you get, there should be a 2 in the bottom, and yeah, and the same thing here. There should be a 2. Yeah, so there should be, it doesn't change the answer, but should be like this. Yeah. Sorry guys about this mess, but when you use the chain rule, you get this, and then you need to differentiate this with respect to t. All right, so when you do that, you have a half and the square root of this in the bottom, and then multiplied by this, and the same thing here. So you get this. All right, so the conclusion doesn't change though. And this is part 2. Now, condition 3 is not going to hold. Condition 3, sorry about this. Condition 3 does not hold because W of f is not finite. I mean, it is infinite actually, so it's not finite. So we have shown that none of the 3 conditions. So this implies that none. Okay, none of the 3 conditions hold. Yeah, that's right, Charlie. Yeah, that's right. That's right, Charlie. That if condition 3 does not hold, if the W of f, the finite upper endpoint is not finite, if it is not finite, then it doesn't hold automatically. Because for condition 3, you must have the upper endpoint finite upper endpoint. So if it's not the case, then automatically it doesn't hold. All right, guys. So once again, I'm sorry for the chain rules. Even I can make a mistake. So you have to be careful with the differentiation. Yeah. But by the way, about the quiz number 9, I noted quite a few people had made mistakes with differentiation. Maybe none of you here, but so I think some other people have made mistakes with differentiating in quiz number 9. I'll try to have them marked later today.
Do we need to memorize some derivatives? For example, this one was R, and do we need to know R or any other derivatives with the test? I would have given this question there.
Yeah. I don't think there will be like complicated functions like this. No, I don't think you will need to remember now. It's just standard functions like, I know arcsine is not so standard. Yeah, I know. But normally anything like exponential or log or power functions and things like that, you should know how to differentiate or integrate.
This was a take-home test, right? It was last year.
Yeah, it was take home. Yeah, it was last year. It was take home. Yeah. Last year was take home. Yeah. All right, guys. Any other questions on this? Okay, let me go back to this. So you just completed doing part B. Any other part you like me to do? This is last year's exam paper. Or any other questions you like me to do, guys? Let me know.
With the question 1,
Three con, okay, yeah. This one, you mean? This one, okay. Yeah, I'll try to do, I'll just show you how to do the first. So this is B1 part C from last year's exam paper. So you're told that f of x is equal to a times g of x. So this will be similar to the question that you will get tomorrow and Friday. So let's assume that G belongs to example domain of attraction. The idea is then abbreviation for domain of attraction. Then there exists gamma t greater than 0 such that all right. Okay, so we need to show that, okay, let me call this condition star, right? We need to show that the same type holds when you replace G by F, all right? So okay, so this is gonna be equal to, now I'm gonna sub this thing here into this, so it's gonna be limit. I'm gonna change WF to WG because you're told that you can do it. The question says that you can. Yeah, in the beginning, you can change WF to WG. Yeah, so all right, I know it's complicated, so sorry for taking so long. All right, guys, so this is what you get. All right, now if you take the limit as t goes to WG, you see quite a few things happening, right? This guy here will go to 1, right? And so is this one here, so is this one. will also go to 1. All right, so what you have is 1 plus b minus b, which is 1, right? So this whole thing disappears to 1. And so is this one. This also disappears to 1. All right, so, and similarly, because GT goes to 1 here, this guy goes to 1, right? And we also know that this goes to 1. This whole thing here is going to go to, it's going to go to A. Do you see that? I mean, this whole thing here, this whole thing here is going to go to A, and similarly, this whole thing here is going to go to A too, right? Yeah, do you guys see it or not? Veronica, are you okay or what?
Yeah.
All right. So what you have is the limit as t goes to WG of the A and the A cancel, so you have 1 minus G plus T plus X gamma T. Then in brackets, you have 1 plus B minus B G, excuse me, G T plus X gamma T. And then in the bottom, you have 1 minus GT times 1 plus B minus B GT, right? Okay, now as T goes to WG, this guy here and this guy here, both of them go to 1. This goes to 1 and this goes to 1 too, right? So what you have is 1 plus B minus B, which is 1, and 1 plus B minus B. So this goes to 1, and this also goes to 1, right? So what you're left with is simply the limit as T approaches W of G of 1 minus G T plus X gamma T divided by 1 minus GT. And this is equal to, because of star, this is equal to E of minus X. The star is what I said before, this is star, right? So we have proved that F and G belong to the same, sorry, if G belongs to the Gumbel domain, F also belongs to the Gumbel domain. And it's similar for the other two types. But you should show, you shouldn't say it is similar. Like you shouldn't say, I know it's easy to say it is similar, but you should work it out. You should do the calculation because you have 24 hours to do the calculations. I mean, you have 24 hours to do complete the test tomorrow. Yeah.
How about like the actual test? Can we just say whatever? Because I think there's a lot of questions and I don't think I'm gonna have enough time.
You mean in the exam? No, I think you should show the full calculations. Sorry. I got one more question from somebody here. Is it Ruyan? Any other questions, guys? Any other questions you need to do? 2006-17. Oh yeah, this one. So what's I got question in 2016-17. Oh yeah, what's the question, sir? Can you tell me what the question is, sir? This is 2016-17 paper. So I can do it if you want me to. So I have time, let me. Sorry, this is a course for test from 2016-17. So you're told that f of x is equal to 1 minus, excuse me, 1 minus, there are too many brackets here. 1 minus 1 minus 1 minus g of x squared, then cube, then 4, right? Then cube, and then to the power 4. Is that right? Yeah. So this is the question on 2016-17 coursework test. Right. In this question, all right, let's try to assume G belongs to a Gumpel domain of attraction. Right, then we know that the limit as t goes to W of G 1 minus f t plus x. Sorry, it should be G, not f. Okay. All right. Now, so what this implies that the limit as okay. Now I'm going to replace W of f by W of g in the first line. Okay. Now the 1 and the 1 here, this one here cancels with the 1 here, right? So you have in the top, you will have the following. You have 1 minus 1 minus 1 minus g of t plus x gamma t, right? Then squared, then cube, then power 4. And in the bottom, you have 1 minus 1 minus 1 minus g of t squared cube to the power 4. You follow me, right? All right, now you see here that as t goes to W of g, this guy here, this guy goes to 1, all right? So what this means is that this thing here goes to 0, right? And similarly, this goes to 0 too, right? You follow me? All right, so now one of the formulas I gave you is this. If you have something like this and z approaches 0, then this behaves like 1 minus 3 times z as z approaches 0. So using this formula, do you remember this? This is one of the things I asked you to remember for the exam, not for the test tomorrow. All right, so if you use this, right, you can see that the about thing will become like this. Okay. You follow me, guys, or no? Yeah. All right, so the 1 here and the 1 here cancels, and the 3 and the 3 cancels. So what you have is the limit right? So a lot of things cancel. So what you have is correct me if I'm wrong. I hope it's correct. Okay. So power 8. So 2 times 4 gives you 8, right? Now using star, now if you use star here, this will become e to the power 8 times x, right? Which is of the same type as Gumbel. So you prove that f and g belongs to the same domain. Belong to the Gumbel domain of attraction, right? So you will need to repeat this for Frechet and Weibel. Okay. Okay, guys. Any other questions, guys? You have to be a little bit more careful with differentiation. Even I made mistakes this morning. Sorry about it. It's easy to make mistakes with differentiation. So try to be a little bit more careful. So yeah. And yeah, for the exam, I mean, as I said before, I will be in Manchester throughout the break, Christmas break, and also in January. So any questions you guys have about the exam, feel free to contact me by email or Skype or Zoom or phone. You have my 2 phone numbers, the office and the home phone number. So any questions, just feel free to contact me. Okay. And today, on Friday, there will be no tutorial because of the in-class test. So we don't. So this is the last class, but I mean, I'll be in touch with you by email, of course, every day. You know, whatever question you have. So I will be. I'll be in touch with you. So, okay. UEQ, yeah.
Where do we do it? Is it on the Blackboard?
You must have got an email from the university. Didn't you get an email? No? You didn't get an email?
Is it on Blackboard?
It's on Blackboard, yeah, it's on Blackboard. I'll send you the link. I mean, I already, somebody sent me a link for the completing the UEQ. You should, I mean, you should know of the links. Can somebody paste it on the Zoom, please? Do you guys know the link, guys? Those of you who are on the Zoom, you should know the link. Can you paste it, please? Oh yeah, it's here. It's this one. Can you see, Veronica, can you see this? It's a long one. I thought there was a short one maybe. Oh, no. This is a long one. That maybe. Anyway, I think I have a short link. I will send it to you later, Veronica, later today. The thing is, yeah, I'll send it to all of you guys in case you don't know the link. Okay. And okay, guys. So once again, yeah, I mean, thank you for taking this course. I hope you like this course, and so I will in semester 2. I don't think I'll be teaching you. I'm teaching a year 1 course in semester 2. So, but I'll be around anyway, so you can see me around, hopefully in person in semester 2. Like, hopefully the things will be online. Sorry, not online. I mean, face to face on campus in semester 2. So hopefully I'll see more of you in ATB. All right, so take care, guys, and good luck for tomorrow. And any questions, just email me. Yeah. Now, you can't ask me questions during the test, but before the test, you should have questions. Please email me. Okay.